This video is for lesson 2-1 about inductive reasoning. The learning goals are to make conjectures by applying inductive reasoning and to recognize the limits of inductive reasoning. The ability to recognize patterns is an important aspect of mathematics. But when is an observed pattern actually a real pattern that continues beyond just observed cases? In this activity, we'll explore patterns and check to see if the patterns hold true beyond the observed cases. Inductive reasoning is the process of observing data, recognizing patterns, and making a generalization. This generalization is called a conjecture. In geometry class, a lot of our conjectures will deal with shapes. Question 1. 5 students attended a party and ate a variety of foods. Something caused some of them to become ill. JT ate a hamburger, pasta salad, and coleslaw, and she became ill. From that sentence, I know that the food that causes the students to become ill have to be either a hamburger, pasta salad, or the coleslaw. Next sentence, Guy had coleslaw and pasta salad, but not the hamburger, and he became ill. So from that sentence, I think it's probably either the coleslaw or the pasta salad that's the culprit, not the hamburger. But it could be one of these items and the hamburger made him sick. Dean had only hamburger and he felt fine. So that changes my mind on wondering if 2 of the food items caused him to be sick. It's not the hamburger. Reading further, Judy didn't eat anything and she felt fine. Cheryl ate a hamburger and pasta salad but no coleslaw and she became sick. So she had pasta salad and hamburger. It wasn't the hamburger, and so it had to be the pasta salad. Coleslaw was innocent of making people sick. So use inductive reasoning to make a conjecture about which food probably caused the illness. It looks like pasta salad caused the illness. That's our conjecture. Question 2, reason quantitatively. Use inductive reasoning, that's where you use observations to find patterns. To make a conjecture about the next 2 terms in each sequence, explain the pattern you use to determine the terms. A, 4, C, 8, E, 12, G, 16. It looks like it's alternating letters and numbers, but in the case of letters, it's skipping a letter. So if we skip H, that takes us to I. In the case of numbers, 4, 8, 12, 16, those are multiples of 4. That's going to be 20. Question B, 3, 9, 27, 81, 243. I recognize these as the powers of 3. This is 3 to the first power. This one is 3 to the second power. This one is 3 to the third power, to the fourth power, to the fifth power. So this is 3 to the sixth power, 729. This one here is 3 to the seventh power, 2187. Question C, 3, 8, 15, 24, 35, 48. These are getting larger. And from term to term, it looks like we're adding increasing odd numbers. So add 5, then add 7, add 9, add 11, add 13. If we add 15, we get 63. And if we add 17, we get 80. Question D, 1, 1, 2, 3, 5, 8, 13. These are also increasing. This is actually a famous sequence that I recognize called the Fibonacci sequence. The term is the sum of the 2 previous terms. 1 plus 1 made the 2. 1 plus 2 made the 3. 2 plus 3 makes the 5. 3 plus 5 makes the 8. 5 plus 8 makes the 13. 8 plus 13 is 21. And 13 plus 21 is 34. Let's move to some geometry now. Use the 4 circles below. From each of the given points, draw all possible chords. These chords will form a number of non-overlapping regions in the interior of each circle. For each circle, count the number of these regions. Enter this number in the appropriate place below. So if I scroll down, we can see the circles that we have to work with. I've already drawn in the chords. So there was a dot here and a dot here. If you draw in one chord, that creates two regions. This one here had 3 dots. If you connect all of the dots together and label them, that's 4 regions. This one here had 1, 2, 3, 4 dots. Again, draw all possible chords. There are 8 regions. And this one had 5 dots. There are 16 regions. And so back to the table, you notice those numbers filled in. Question 4. Look for a pattern in the table above. Part A. Describe in words any patterns you see. It looks like with each additional point, that doubles the number of regions, right? So when I increase the dots around the outside by 1, it went 2 times 2 makes 4. When the number of points increased from 3 to 4, it went 4 times 2 makes 8. Again, increasing by 1 point, it looks like 8 times 2 makes 16. So there is my pattern. Now question 4b. Use the pattern that you described, that it looks like the number of regions is doubling, to predict the number of non-overlapping regions that will be formed if you draw all possible line segments connecting 6 points. Well, using our pattern, we'll take where we left off, 16 regions, double it, and predict 32 regions. Here's some check your understanding questions, so I'll pause the video for you. Okay, recall that we left off with this situation of having a circle with points on the circle and then drawing all possible chords to see how many non-overlapping regions are created. Question 7, use the circle on the next page and draw all possible chords connecting any 2 of the 6 points. So here on the next page, you'll see a circle with 6 dots on it, and I have drawn all possible chords and then numbered them in the brown ink. And when I finally got done, there were 31 of them. So question A, what is the number of regions? 31. Question B, is the number you obtained the same number you predicted from the pattern in the table earlier? The answer is no. We predicted 32 regions. Question C, describe what you would do to further investigate the pattern in the number of regions formed by chords joining n points on a circle. So we're using the variable n to represent any number of points we want. Well, what could we do to further investigate? We could try 7 points, or we could draw a circle and put 8 points on it and draw the segments and count the regions. The point is that we need to try further instances. It looked like we had a pattern for a few examples, but when we tried further examples, the pattern no longer worked. Question D, try to find a new pattern for predicting the number of regions formed by chords joining points on a circle when 2, 3, 4, 5, and 6 points are placed on the circle. Describe the pattern in algebra terms or in words. So here I've made a little chart, number of points, number of regions. I've copied from the previous chart a lot of the information, but notice for 6 points, instead of 32, I filled in the correct result of 31. If I was to make a circle with 7 points and find out the answer, it turns out to be 57 regions. So with these additional values, I can work again to find a pattern. The way that I approached this was actually using a graphing calculator and the statistics feature on the calculator that you learned in algebra class. I created a list with these numbers as the x and y values, and then performed a regression to see what kind of formula the calculator used to show how the dots line up in a particular curve shape. The best fitting curve was a quartic or 4th degree polynomial. And here is that polynomial that the calculator gave me. This, of course, is not the important part of today's lesson, being able to use the calculator and to do that algebra. We're not in algebra class. The main idea from today's lesson is that if you're using inductive reasoning, you have to consider enough samples to make sure that your pattern or your conjecture really works. If you limit yourself to too few examples, you might find out that you think something's true, but really isn't. Here are a few more check your understanding questions. I'll pause the video for you. So in this video, we discussed making conjectures by using inductive reasoning. Inductive reasoning is observing data or observing examples to try to find patterns. We also talked about the limits of inductive reasoning. If you only use a few examples or you think of the wrong examples, your conjectures might not really be true.